So we are going to solve lesson 3A, understanding rational and irrational numbers. Remember that before this lesson, so this is the key for the homework. So remember that before this lesson, you need to know how can you convert fractions to repeating or terminating decimals. And that's what we've been doing in class. That was the lesson for the last week. Remember that study the example problem showing how to use division to express fractions as a repeating decimals. Then solve problems 1 through 7. We've been solving those kind of problems in the class. So what I'm doing is here helping you a little bit. So let's read through the example. For example, I have Erica uses division to write 1/3 and 2/3 as decimals. First, she estimates that because 1/3 is between 1/4 and 1/2, it will be between 0.5 and 0.25 and 0.5. Likewise, because 2/3 is between 1/2 and 3/4, it will be between 0.5 and 0.75. Then she divides as shown at the right. So 1/3 is equals to 0.333 or 0. Dash, and we did that one in class. So then we have 2/3 equals to 0.666 or just 0.6 with the dash on top. Now let's answer the questions. You have those divisions there that we've been doing in the class. If you review the Zoom videos, you're going to find those kind of divisions that will help you. So let's go over question number 1. It says, Erica says that no matter how many decimal places she divides to when she divides 1 by 3, the digit 3 in the quotient we just keep repeating. Is she correct? Explain. So in this case, remember that the division is already here. They did the division, okay? And we have 0.333 and keeps repeating. So in this case, Erica says that no matter how many decimal places she divides to, when she divides 1 by 3, the digit 3 in the quotient will just keep repeating. Is she correct? Explain. Yes, it is correct. Okay? Yes. And you can see it here. So 0.33, and we keep repeating all the way. So what is the reason? So she keeps, in this case you can write, she keeps subtracting 9 from 10 and dividing 10 by 3. So the digit 3 keeps repeating. So this example, for example, if I let me see if I can move. Let me see if I can switch the camera here. So what she got in this case is the following division. So she has 1/3, right? We're talking about 1/3. And then she says she's dividing 1 by 3. So what we're going to have is 3 divided by 1. But it's not possible because 3 is bigger than 1. So there is no number that multiplied by 3 will give you 1. So in this case, we add a 0. And we add a 0 in the quotient and a decimal point. Now you have 10 divided by 3. So which number multiplied by 3 will give you 10 or less than 10? And that one is 3. 3 times 3 is 9. And then 10 minus 9 is equals to 1. Okay, so we add a 0 because we ended in the same situation. See, and then you have 10. So we 3. 3 times 3, 9. 1. And then we add 0. 3, 9, 1. 0. 3, 9, 1. 0. 3, and so on. So in this case, 1/3 is equal to 0.3, and we draw the dash because it's just keep repeating, and all this operation keeps being the same and the same and the same and the same. So in that case, yes, it keeps repeating every time because Erica says that no matter how many decimal places she divides, we're always going to repeat the same number. So let's move the camera. So in this case, the answer is yes. So number 2 says, is the decimal for 4/3 a repeating decimal? Is the decimal for 4/3 a repeating decimal? That one is yes. Okay? Yes. When I divide 4 by 3, the 3 keeps repeating. In the quotient. For example, okay, let's do that one. Let me switch the camera. So we're going to do that one. Let me erase. So I have in this case, now is the division. We're talking about the fraction 4/3. So that means we're going to have, this one is 3 divided by 4. Okay, so we use the operation. We know that the first one is 1 times 3, 3, 1. Okay, there is no number that multiplied by 3 will give you 1, so we add a 0 decimal point. Now we do 3 times 3 is 9, 1, 0, and see how the pattern goes. 3, 9, 1, 0, 3, 9, 1, 0, 3, and so on. So 4/3 is equals to 1.3 with the dash because the 3 keeps repeating and repeating and repeating and repeating. So it's a repeating number. So question number 2 is yes, when I divide 4 by 3, the 3 keeps repeating in the quotient. So in this case, question number 3, how could Erica have used the decimal that she wrote for 1/3 to find the decimal for 2/3? And in this case, you can say the decimal for 2/3 is double the decimal for 1/3, which makes sense because 2/3 is twice as much as 1/3. Okay. Remember the vocabulary word that we are saying is repeating decimal. It's a decimal that never ends. For example, this one 0.33333333 keeps repeating. That never ends. But instead repeats the same digit or a group of digits over and over. For example, we know those ones are repeating a decimal. So this one is for page 23. Let's move to page 24. So in this case, solve. They are asking me, okay, write the decimal for 1/8. Explain why this decimal is called a terminating decimal. Remember, terminating decimal, you have the vocabulary words is a decimal that ends or terminates. For example, 0.5, 4.08, 0.300, and so on. So in this case, you have 1/8. So let's do the division. Let's do the division. Okay? So let me raise here. Let's do the division for that one. So I have 1/8 going, okay? And we are going to divide by 1. Okay? In this case, there is no number that multiplied by 8 will give me 1, so we add a 0. 0 in the quotient, decimal point. Now, if I multiply by 1 times 8 is 8. 10 minus 8 is 2. Okay, we are in the same situation. There is no number that multiplied by 8 will give you 2. So you add a 0. You don't add, in this case, a decimal point. Only once. And once repeat the 0, okay, now you have 8. So which number multiplied by 8 will give you 20 or less than 20? In this case is 2. 2 times 8 is 16. 20 minus 16 is 4. And we add a 0 because there is no number that multiplied by 8 will give you 4. And now you have that 5 times 8. Wait. This one is, in this case, is 5 times, yes, 5 times 8 is equals to 40. And then you have a remainder of 0. And we can say that 1/8 is equal to 0.125. It's a terminating decimal. So 1/8 got a terminating decimal. So let's answer the question now. So the question is, write the decimal for 1/8. So we know that one. So 1/8 is equals to 0.125. We did that one in the whiteboard, in the chalkboard. So in this case, explain why this decimal is called a terminating decimal. Because you can, because the decimal ends or terminates. Okay? Number 5. Tell whether each statement below is true or false. If it's false, write an example that proves the statement is false. So you need to prove it that it's false. All fractions can be written as a repeating decimals. All fractions, listen to the question. All fractions can be written as a repeating decimals. That's false. That's false. Okay? That's false. Why? Because, as you know, the example that we have here, 1/8, is 0.125. That one is a terminating decimal, and you can use it as your solution. False. 1/8 can be written as a terminating decimal. In this case, you can show that 1/8 is equals to 0.125. And that's the solution for problem number 5. Now let's do the second part. If a fraction can be written as a repeating decimal, only one digit can repeat over and over without n. Well, that's not true, so it's false. And you can use your textbook to find those other decimals. And in this case, I'm going to provide you an example. And the example is, let me change the camera here. And the example that we can have is 1/11. That's one example of many, right? So 1/11 Okay, if you divide those two numbers, this is 11, this is 1, and look what's going to happen. So 11 is too big, so there is no number that multiplied by 11 will give you 1. So you have 0. Now the problem, so 0 and decimal number. The problem here is still 11 is too big of a number than 10. You don't have a number that multiplied by 11 will give you 10 or less. So we add another 0 and we add a 0. Okay, we add a 0. So what we do now, okay, we multiply. So which number multiplied by 11 will give you 100 or less? So in this case is 9. 9 times 11 is 99. 100 minus 99, 1. And we follow the same steps. 0, still too small. If you add another 0, you add a 0. And then 9. 9 times 11, 99. 1. And see how the pattern goes. 0, it's too small. Another one. 0. 9 times 11, 99. 1. And then, see how it repeats? 10, too small. 0, add a 0. 9, 99, 1. And it keeps going and it keeps going and it keeps going. So in this case, 1 over 11 is equals to 0.0. Or you can type it as 0.09, which the question says, if a fraction can be written as a repeating decimal, only one digit can repeat. That's false because we have two digits that repeats. So let's answer the question. I already said it's false. I already said it's false. For example, 1 over 11 is approximately equals to 0.090909, or 1 over 11 is equals to 0.09 with the dash, okay, which has two repeating decimals. Okay, that's question number 5. Let's do number 6. Raj is playing a game. He needs to find a pair of cards that have the same value. Which two pairs of cards does Raj have to have that express the same value? So look at 7 over 9, 3/8, 3/5. The only way to know is to make the division. And we're going to do it here. So in this case, I have 7 over 9 is equals to 9 divided by 7. Okay, 7 is too small, so we write 0, 0 point. Which number to multiply by 9 will give you 70 or less? So let's try 7. 7 times 9 is 63. 70 minus 63 is 7. Okay, so we got same situation, 0. So we are going to type here which number? 7 again times 9 is equals to 63. 7. And see how that keeps repeating and repeating and repeating. So 7 and 0, 63, 7, and so on. So in this case, what is the same? So I have 7 over 9 is the same as 0.7 over 9 and 0.7. So those two are the same. Let's find another one. I'm going to do the division of 3/8. Here, 3/8. So it's 3 is too small, 0. So it's 0 decimal number. Which number multiply? 3. 3 times 8 is 24. 30 minus 34 is 6. Too small of a number. 0. Which number multiplied by 8 will give you 60 or less? So in this case is 7. 7 times 8 is 56. Okay, so what we have 4 at 0, which number multiplied by 8 will give you 45. So it's 40. Reminder, 0. So that one is a terminating decimal. So which one? So I just did 3 over 8. So here it is. So 3 over 8 and 0.375. They only asked me for 2. I'm giving 2. So that's it. And number 7, we're almost done. Write each number in the appropriate box to show its placement along the number line. Okay, so I'm going to start with this first number, negative 2.8. So I have negative 1, negative 2. See that this is the only box that we have at the left? So that's negative 2.8. So this one, gone. Okay, what else? I have 2/3. Okay, 2 over 3. 2 over 3, as you can see, I'm going to type 2 over 3. The numerator is less than the denominator. That means that this number is between 0 and 1 by definition. So it's between 0 and 1. So you have 2 boxes. So it has to be, see this one, 0.25. So I have 1, 2, 3, 4. So every line counts as 0.25, 0.25. So I already found this one. So that means this one is 2 over 3. Gone. Okay, let's move to the next one. 2.16 repeating. 2.16. So I have 2. Here is 2.16. That's the only one. So this one is 2.16 repeating. Gone. What else do I have? I have 1/7/8. See, that's the only one that is left here in the positive side. So this one is 1/7/8. And the only one negative, negative 13/9. And that's the solution for the first 2 problems. That's assignment. Don't forget to submit your homework in Google Classroom. And remember, this one is just page 23 and page 24 of your instruction book. And you can take a picture with Google Chrome of the assignment, submit your assignment so you can get full credit. Doesn't matter if it's late, you still have today until Sunday and you're going to be fine. So I hope you have a wonderful evening, and if you still have any question, don't forget to let me know, and during the intervention block I will be able to help you. So you have a wonderful day.